We are the Gujarat Technological University. Since its inception over a decade ago, GTU has been empowering young and curating minds to realize their true potential. Over 4 lakh inspired students are enrolled with one of the premier academic universities in India. With more than 450 affiliated colleges in its fold operating across 5 zones of the state, GTU, the International Innovative University, your place to move forward.
Dear students, I welcomes you in the second lecture of subject Basic Transportation Engineering for unit number 2, Road Materials and its Construction Aspects. There are 6 main topics of this unit. First is road pavement, and in road pavement subtopics are types of pavements, factors affecting selection of pavements, pavement components and pavement thickness. Types of pavement and factors affecting selection of pavement is covered in first lecture. In this second lecture we cover pavement components and pavement thickness. There are 4 basic components of flexible pavement. Starting from bottom, soil subgrade having 300 mm thickness, sub-base course having 300 mm thickness, base course having 100 mm thickness, and the top layer surface course is 25 mm. Soil subgrade is compacted layer of soil, works as a foundation for pavement. So its function is to transfer the wheel loads from upper layers of pavement to the ground without deformation. When road is constructed by filling, the soil subgrade should be well compacted, having thickness of 300 mm. But when road is constructed by cutting, the soil subgrade is naturally hard, so does not require major compaction work. Compaction is done by heavyweight roller in controlled condition of optimum moisture content, which gives maximum dry density. If soil is cohesive, 15 cm thick layer of coarse sand is used over soil subgrade. The compaction work for filling should be carried out in controlled conditions of optimum moisture content and maximum dry density. This graph shows that 1.78 gram per centimeter cube dry density is maximum, which gives moisture content in between 7 to 8%. So a soil which gives this graph in lab testing, we use optimum moisture content in between 7 to 8% for its compaction work. Subbase course is 300 mm thick compacted layer constructed over soil subgrade to increase the bearing capacity of soil subgrade. It also improves the drainage property of pavement by restricting the capillary rise of groundwater. Capillary means Kesakarshan. It is prepared by boulders of size 180 to 120 millimeter. Boulders is a large size stones. Dry rolling is done by 8 to 10 ton weight roller. Base course is 100 millimeter thick compacted layer constructed over subbase course to increase the bearing capacity of subbase course. It also provides level surface for surface course. It is prepared by coarse aggregates of size 90-40, 63-40 and 50-20 and grit of size 12.5 millimeter or 10 millimeter. Dry rolling for coarse aggregate and wet rolling for grit is done by 8 to 10 ton weight roller. The width of base course is kept 30 cm more than the varying course on each side of the pavement, 30 cm equivalent to 1 feet. The requirement for base course materials, as this course is just under to the surface course, it should be sufficient thick for proper distribution of wheel load, sufficient stable to resist vertical load, sufficient dense to resist consolidated pressure, sufficient resistance against weathering action. The surface course, also known as wearing course, is 25 to 50 mm thick impermeable top layer constructed over base course to provide smooth riding surface and to prevent the entry of rainwater into the lower layers. It is made by bitumen and grit. Minimum content of bitumen is 4%. Bitumen of proper grade is used based on penetration value and viscosity. Road pavement thickness. Road pavement thickness is considered without soil subgrade. It depends on compressive strength of soil subgrade. That means road pavement thickness depends on compressive strength of soil subgrade. Higher the strength, lower the thickness of pavement. Measurement of soil strength. To measure the strength of soil subgrade, California bearing ratio test, in short CBR test, is performed in transportation lab. It is penetration test for soil sample. CBR percentage taken at 2.5 mm or 5 mm penetration of plunger. CBR percentage equal to load on soil divided by standard load on rock multiplied by 100. Soil samples are prepared in soaked conditions, 72-hour soaking, and unsoaked conditions. Soaked CBR is considered when drainage is poor around the road alignment. Generally, clay material have CBR value around 2%, sand around 10%, and gravel around 15%. For soil subgrade, minimum CBR is 6% according to standard. To watch the CBR test video, go on website of National Institute of Technical Teachers Training and Research, Chandigarh, in short NITTR, or the video generated by any standard soil test lab or transportation lab. This is CBR test apparatus. In right figure, proving ring is shown and the gauge in proving ring measures the load. Other gauge is measures penetrations of plunger. After the performing of CBR test, the graph generated versus penetration versus load. The red line is not gives a uniform relation, so for getting uniform relation between penetration and load, this graph is modified or corrected as shown in figure. In this figure, the 0 point is shifted a new position in right side. CBR value is considered for 2.5 mm and 5 mm penetration of plunger and taken in design of pavement thickness, which is maximum. Here 2.5 mm and 5 mm penetration gives the load in kilogram per centimeter square. The standard load on rock is shown in this table. For 2.5 mm penetration of plunger, standard load for rock is 1370 kg, and for 5 mm penetration, the standard load on rock is 2055 kg. CBR calculation. Suppose observed reading in load dial gauge for 2.5 mm penetration of plunger is 20 divisions. In proving ring. The proving ring factor is a total measuring capacity of proving ring dial gauge divided by numbers of divisions of dial gauge. We assume proving ring factor 1.38 kg per division. So load on soil sample is 20 divisions multiplied by 1.38 kg gives 27.60 kg. Now CBR percentage is load on soil sample divided by load on standard rock. For 2.5 mm penetration, load on standard rock is 1370 kg. So CBR percentage is 2.014%. For deciding depth of pavement, this graph is used. In this graph, in x-axis, CBR percentage is shown from 2 to 100, and in y-axis depth of construction in millimeter from 0 to 850 millimeter. In this graph there are many lines are shown: line A, line B, line C, line D, line E, line F and line G. What represent these lines? The curve A means a road have a traffic classification, number of vehicles per day exceeding 30 kilonewton load and weight, that means 3000 kilogram load and weight, means for a road if traffic data gives, according to traffic data, if number of vehicles per day which have loading weight more than 3000 kilogram or 3 ton is in between 0 to 15, for that type of road curve A is used. Curve B is used for 15 to 45 numbers of vehicles per day exceeding 3 ton load and weight. In our calculation, CBR value is 2%. So our line of CBR percentage is the first vertical line, which is CBR value 2% line. On this line, this vertical line, we find the thickness of road pavement or depth of construction. Suppose we consider the traffic classification curve D, 150 to 450 numbers of vehicles per day exceeding 3 ton load and weight. For traffic curve D and CBR value 2%, the arrow gives the depth of construction is 600 millimeter. That means the total thickness of road pavement including subbase, base and surface course is minimum 600 millimeter. In this way, CBR value is used for different categorized road to find the thickness of pavement. So today we cover two subtopics of first topic, road pavement. If you want to learn better, try to make class note using the video lecture in your language and select correct answers for given M.C.Q. The M.C.Q is given as assignment work, which is already send in our group. Thank you.